Have you ever typed exactly what you're looking for into a search bar and gotten completely useless results back? Yeah, we've all been there. It happens because traditional search systems are incredibly limited. They don't actually know what you mean, they just know the letters you typed. Let's fix that. Today, we're diving into one of the most important concepts in artificial intelligence, embeddings. This is how AI actually understands what we mean.
Okay, let's jump right in. Think about the phrases fast car and quick vehicle. To you and me, those mean the exact same thing. But to a traditional keyword search, total failure. It completely misses quick vehicle when you search for fast car because a basic system is literally just matching letters. It misses the meaning completely.
And that's exactly where embeddings come in. Simply put, embeddings are AI's secret mechanism for converting text into a numerical representation of meaning. For good visual, just think of embeddings as massive, digital maps of ideas.
If you remember only one thing from this explainer, make it this. Embeddings turn meaning into location. I'll say it again, they turn meaning into location. They take our messy human ideas and assign them highly specific coordinates on this digital map.
Picture a giant, three-dimensional space in your head. Words with similar meanings, like dog, puppy, and canine, aren't just isolated words anymore. On this map, they're clustered incredibly close together, like little glowing nodes. They live in the exact same neighborhood because they share the same semantic meaning.
On the flip side, look at what happens to totally unrelated concepts. Think about pizza, a galaxy, and a hospital. They have absolutely nothing in common. Because their meanings are so wildly different, they get pushed super far apart into the dark, empty space of the map. They're basically light years away.
So how does this actually work? It follows a clear sequence. An AI model takes your text input, processes it, and converts it into a vector, which is really just a list of numbers. Those numbers then serve as precise coordinates plotted as a single point on our meaning map. Depending on the model, you might have 384 numbers, or over 3,000 numbers defining just a single word. But don't worry, you absolutely do not need to know the complex math here. The crucial takeaway is just that meaning becomes mathematics. It's the overall pattern that matters. And this illustrates why all that math is so powerful. Let's say you use a semantic search for management strategies. It effortlessly connects you to documents about leadership approaches. It's not playing a letter matching game. It knows their locations on the map are nearly identical. Instead of asking, do these words match, the system is asking, do these ideas mean something similar?
This isn't just some abstract theory. These precise maps of meaning are exactly what power the recommendation algorithms for the platforms we use every single day. Netflix, Spotify, Amazon, YouTube, they all rely on this similarity. They find the exact coordinates of your preferences and recommend content located right next door to it.
It also powers the engine behind modern AI capabilities, specifically Retrieval Augmented Generation, or RAG. Here's the flow. A user asks a question, and that question instantly becomes an embedding. A vector database then scours the map for similar meaning nearby, retrieves the most relevant documents, and finally, a large language model uses that perfectly matched info to generate an accurate answer. Without embeddings, RAG is just old-school keyword matching. With them, it truly understands.
Bringing this all together, we humans communicate through language and concepts. We inherently understand ideas. Computers, well, they only understand numbers.
Embeddings are the ultimate bridge between those two worlds. They transform our human meaning into cold, hard mathematics. It's why modern AI systems can search, recommend, and reason in ways that feel surprisingly human.
Which leaves us with a pretty fascinating thing to consider. If AI's incredible ability to seemingly understand us is fundamentally just high-dimensional geometry, what else about human thought can we map?